This is David surrounding this, and I'm going to be going through Discrete honors problem 4 with SKIPLIST and binary search trees. So I'm going to talk about both and inserting and removing data with coin flips in the case of the SKIPLIST, and it's going to hopefully will demonstrate the difference between the two. I'm going to use instructions given on the website here, and as I follow through them, we can go. So the first step is to insert 20 and use coin flips 110, 110, 20, 110. Well, that goes. We just insert 20 here. Now we insert 40. And just remember that 110 means that SKIPLIST would increase the steps by 1. So these two steps would have a 1 value over here. And when the final value is a coin flip value is 0, it doesn't continue, so it stops. And when we insert the value in the binary search tree, it will create a rule, and there's nothing else, just a rule, as it's just a basic binary search tree with nothing else present. Now it wants us to insert 40. Perfect. Now it wants us to insert. Well, this is David surrounding this, and I'm going to be going through. So, essentially, at least in the binary search tree case, we know that when we insert the 40, we know that it's going to be greater than 20, so it becomes the right child, and 10 is less than 20, so it becomes the left child. In this case, you can see that since 10 is less than 20 over here, it ends up going to the left of 20. And since 40 is greater than 20, it comes to the right. And at the lowest base for the level, the coin flip resulted in 0. At least it seems like in this case. Okay, so let's see. Now the next part, we want to insert 20, insert 5, 8, and 80. Okay, we got a lot of things, so I'm just going to do 20 first. Okay, it seems like one. Okay, 25, 80. Now we want to delete 20. Insert 100. Now we insert 20 using coin flips 10. I'm just going to insert 20 to the binary tree, or binary search tree. Okay. So we inserted 5, 80, and 20. We end up noticing that 5 is less than 20, making to the left. And it's also less than 10, so it's to the left of that number as well. And the coin flip suggested that the coin flip ends up suggesting that in the position of 5 suggests that the coin flip value is 0. Now that we insert 80 afterwards, and 80 being less than 20 ends up being to the right. 80 is greater than 20, so it's to the right. And 80 is also greater than 40. Okay, and we ended up removing 20 as well, and this also applies to the. Actually, I'll discuss the binary search in a second. So then we removed 20, which was removed, which removes it and shifts all the values to the left. And then we insert 100. And since 100 is greater than 80, to the right of 80. And then we end up inserting 20 back. And then we look at 80. We go back and then we look at 40, and we notice that 20 is greater than 10 but less than 40. So it ends up staying here. Now let's look at the binary search tree and talk about kind of just what we did as well. So we ended up inserting 5, which is less than 10. And actually, in this case, I think we had 20, but we ended up deleting it later. But it was less than 20 and 10, so it ends up becoming the left child. And then we also inserted 80. And the root was initially 20, like I said before. 80 is bigger than 20 and 10. And it was also greater than 40 that we had before, I think. Yeah, we had 40 before. So it ends up becoming the right child of 40 as it was greater. And then we deleted 20, like we said, which ends up shifting or changing the root and basically making the root of the tree 10 instead of 20 from like the beginning. And then we later insert 100, which is greater than 10, greater than 40, and greater than 80, becoming the right child all the way down here. And then we, after that, inserted 20 back. Since 20 is greater than 10, but it's less than 40, it occupies this spot right here. And since it's, yeah, and then it occupies this spot right here. Now we're going to insert 30. And then we delete 5. Since, okay, so since 30 is greater than 20, but less than 40, it's placed right here. And the 5 is removed. So all the values in the skip list were actually shifted. But in the binary search tree, we check if 30 is greater than or less than 10. It's greater than 10, obviously, so it goes to the right. And okay, so then, and it's also greater than 20, but it's actually it's less than 40, so it should be to the left, greater than 20, so it's to the right, and it ends up becoming the right child of 20. Now we're going to insert 50. Now I want to look up 80. So when we look up 80, it starts at the top left, then it goes to the right until it finds the highest value, and then it goes down, and then it finds it from there. From the binary search tree. So it starts at 10, finds it's greater than 10, so it goes to the right, and it finds greater than 40, so it goes to the right, but then it lands it right at 80.